Hello, everyone, and thank you for joining us for this very exciting panel on AI and finance. But before I start, I would like to thank Ziv Katzir and all the participants from the previous session for a great session. Just give me a second. I will put up my presentation and we can start. Okay. So we have three great, fascinating panelists with us today. Reuven Shnaps from Ernix, Amit Avori from Meta, and Professor Dino Levy from College School of Management. And I'll introduce all of them in detail in a bit, but believe me, they are fascinating people. But before that, I would like to start with a few words. When you give a professor a few minutes to talk, obviously I have what to say. So let's start with full disclosure. For those who don't know me, my name is Professor Dan Amiram. I'm the Vice Dean and Joseph Safra Chair in Capital Markets and Financial Institution in the College School of Management at Tel Aviv University. I'm also a board member at Mercantile Bank and on an insurtech company, Wisher Global Tech. So I'm pretty familiar with the topic in hand, and I'm also a founding partner in Cytactic Cyber Technologies. And what I would like to talk to you, to take a few minutes to talk to you today, is about some AI applications in the field of finance and the regulatory challenges that we see when we address them. So this is my presentation is based on a work that I did together with Professor Asaf Hamdani from the law school, Professor Colby Castile from the law school, and Dr. Aria Chiaz from the business school for the Israeli Justice Ministry. So obviously, I would like to say that none of my views here represent any of the opinions of my collaborators or obviously the Ministry of Finance. Those represent only my opinions, and we'll stick with that. So when we're reviewed, with the goal of this work that we did for the Ministry of Finance was to review what are the major fields of AI in finance, what are the challenges in regulating those fields, and whether we have some regulation around the world that we can probably or possibly take example and use them in Israel. So when we try to survey AI applications around the world, we kind of group them into 6 main groups. So the first one, what you see on the top left of my screen, is probably most basic AI algorithm of algo trading. So there are a lot of AI applications in algo trading, essentially when a machine do trading. The second big field or big application in AI and finance is robo-advising. So essentially when a customer engage with a robot or with an AI algorithm to advise him or her on how to invest. The third popular field are chatbots or robo customer care. The fourth field that we see is credit underwriting, so giving a loan using computer services or algorithms. The fifth large field is insurtech. An application, the main application in insurtech is, and I'm sure that one of our panelists is going to talk about it, is insurance underwriting. And the last one, when we review the field, is compliance, using of AI in compliance and regulation. Obviously, there are more fields in finance that AI is used, but those are probably the main ones. And while every one of them has its regulatory challenges, I would like to speak about a few ones that go across all those fields. And the first one is data. And we have significant regulatory challenges when it comes to data privacy, data protection, and the use of private information. And let me give you a couple of examples. For example, are you allowed not to give a loan or not to extend credit to a person who's not willing to share its personal data with you? And that's a complicated regulatory question that I'm sure will be addressed in the future. Another issue is, well, are you allowed to use missing data or data that is not incomplete when you train your database? For example, can you train a database for credit in Israel when you don't have the Arab population in it? I don't know. It's a question to answer. Another issue is, well, there are competition issues here, right? So the incumbents obviously have access to more information, and how do you let new players into the field? So that's another issue when it comes to data challenges when it comes to AI. The second issue I would like to raise is probably the most significant problem that I see when it comes to regulation of AI, is the black box problem, or explainable AI, or essentially unexplainable AI. In many AI algorithms, like neural networks, you cannot back out the reasoning of the model or the explanation that the model splits out for the decision that the model spits out. And then the question, let me give you an example. For example, let's say that you don't feed the data to the model that says, well, this person is an Arab or race, right? But the model itself can figure out that if this guy is a pharmacist and drives 30 minutes to work, he's probably an Arab, and you will never know. And the model can potentially discriminate on those issues. And then the regulatory questions that arise are, well, does the individual have the right to ask for an explanation? How even to regulate that? What can the regulator do? And we can go further. Obviously, this also raised a point that goes through AI algorithm of discrimination. While AI potentially solves discrimination problem, discriminating with data is possible, but I will not go into that. And the last point I want to raise before I'll introduce our great panelists is, if you think about it, whether humans have the right to ask anyone who uses AI in finance for human intervention. And that's a big question in regulating all of that. So I will stop now, and hopefully I gave you a few ideas of the problems that are related to AI when it comes to thinking about regulating them in the area of finance. But now I know we're all looking forward for our panelists. So the first one I would like to introduce is Reuven Shnaps. Reuven is the Chief Analytic Officer of Earnings. He directs the Earnings Analytical and Machine Learning Strategy Research. He spent more than 25 years developing, analyzing advanced statistical and economic models. He has significant experience in the field. Before that, he worked for Deloitte in the United States, and he's going to talk to us about contextual multi-arm bandits meets causal inferencing. Thank you, Reuven, and I look forward for your presentation. Reuven, you're still on mute.
Okay, can you hear me now?
Yes, we can.
Okay, and just want to make sure that you can see the screen that I shared with the title. So first of all, thank you very much, Professor Amiram, for the intro, both of myself, but the topics that you mentioned. This is really interesting topics. And by the way, I would love to have a session and a panel just on that, on a different setting, so we can invite the organizer to maybe arrange such a setting in the future. So hello, everyone around the globe. It's really great to be here today. Like many of you, I wish we could have done this in person, but there is always hope for next year. Today, I'm going to talk about a different usage of multi-arm bandits, but before doing that, I'd like to give some context and also spend a couple of minutes about Earnings, and I'm also inviting you to visit our page and reach out to us. In the last few years, we see a significant change in the insurance industry. The statement we see here are made by Tom Wilson. He is the CEO of the second largest insurance company in the world, in the United States, and one of the largest in the world. And it's quite amazing for a traditional insurance carrier to see themselves as a data and technology-driven company. We are start seeing similar trends with respect to some of the other big players around the globe that understand the importance of data and analytics for them to compete effectively in the market. These traditional carriers are being challenged by new players, the insurtechs, the fintechs, Lemonade, Roots, and others, who are not bounded by old legacy system. And these insurtechs are relying heavily on advanced and new technology. Earnix is an established global leader and a provider of an advanced AI-driven rating, pricing, and product personalization solution for insurance and banking. We have global presence with over 90 customers and some of the largest insurance companies and banks in the world in over 30 countries. And over the last few years, we have been experiencing significant business and people growth. Last year, we almost doubled our number of employees. We have been recognized by the industry as innovators and as analytics, ML, and AI leaders, and won multiple awards. We have within Earnix a dedicated analytics team and a lot of data scientists that are focused on researching some of the hottest topics today in AI and ML. Professor Amiram, you mentioned explainable AI, model diagnosis. There is a lot of stuff that we also do there. We focus on designing analytical applications and solutions that create business impact and address needs across an entire spectrum of business professionals, from data scientists all the way to business executives that also need to trust ML and AI. And through Earnix Labs capabilities, we are also able to bring our latest innovations to customers quickly, to have them test it and try it early on and provide us with valuable feedback. So if anyone is interested in working on any of these topics and want us to help transform the world of insurance and banking, please reach out to us. We have many openings of technological and data science position at different levels. Now, when it comes to selling an insurance and a banking product, it's quite unique and it's very different than e-commerce and retail products. First, the products that are being sold are quite complex, and the layperson on the street finds it's very hard to understand what is the product that would be best for them. There is also sometimes complex customer buying journey. There are different selling channels, and each one has potentially a different offering. Now, getting the price right is critical for every product, but definitely for insurance and banking. We have complex cost structure, and the cost that depends on individual characteristics, risk behavior. It's not easy to estimate. In addition, we have the demand side. We need to understand customer attitude toward risk and pricing, account for market forces, competition. And as such, setting the right price is quite complex mission, but indeed a very critical one. To add to that, in many countries, and for core products, this is a highly regulated industry that imposes certain restriction on the proposition and the pricing we can offer, and hence make it even harder to set up the correct prices or come up with the right offering. So leveraging data analytics and ML AI and some of the methods we showed before is pivotal for companies to address these unique aspects. Now, one of the key fundamentals to get the right price and what product to offer is to be able to estimate properly the causal effect that changes to prices or that specific package offering will have on customers' propensity to convert or renew a policy, for example. Ideally, to properly estimate causal effect, it usually requires randomized experiment. This will ensure that we are not only controlling for the observed or known factors, but also for unknown factors, and that guarantees a clean effect. Because of the importance of random experiment, we often see researchers and companies trying to rely on what I call natural experiment. The recent economics Nobel Prize was awarded for that, or pseudo random experiment as an alternative when it's not feasible or possible to run such experiment for different reasons. In the context of pricing, for example, imagine the following simple experiment. We assign people to 3 groups, a price increase of 5%, a decrease of 5%, and no change. This will allow us to estimate the causal effect of the price decrease and increase, or an increase. We can do interpolation between 0 to 5, or maybe extrapolate a bit beyond 5. Of course, we can design a more elaborate test and have more groups. In a similar manner, we can design a test for estimating the causal effect impact of offering a particular product or a product bundle on conversion rates. If we were just talking about 3 options, we can design a simple test similar to the price test, but in reality, this is often much more complex, as every product could have multiple add-ons, and this generates many combinations of product bundles that we need to consider. While the randomized experiments are, as I said, are very effective to estimate the causal effect, often financial institutions might be reluctant to run them for an extended or the needed period of time, or not even at all for different reasons. Since when we assign a product or price randomly, this can either lead to providing non-relevant offer for customer, which the business might feel uncomfortable with, or during the period of this random assignment, this could actually lead to some sort of a loss. And relative to the current strategy, for example, we can lose volume, we can lose profit, we can customer satisfaction can go down, risk can go up, and therefore this randomized experiment might be too expensive for the companies to run. We all know, I guess most of you know, the MAB as a classical example of reinforcement learning, and typically we use the MAB framework. It's an outstanding tool when it comes to launching new products. We don't have information, or when we want to quickly assess and respond to changes in consumer behavior. I would want to offer here a different usage of the MAB algorithm, or the contextual MAB algorithm. We can view it as a smart extension of the price and package testing framework. We are currently at Ernix exploring the applicability for this for designing efficient price or package tests and tailoring personalized and product package offering to customers. There are different types of MAB algorithms: epsilon, greedy, Thompson sampling, UCB, exponent foreign, to name a few. The way it works, you can see here the nice octopus with multiple arms, in a casino. This is kind of the classical example, but we observe a profile. We have a possible action to choose from. We choose an action, we see a reward, and then we update the model. It works that the MAB algorithm automatically manages this exploitation trade-off and trying to maximize a business objective. Now, what if we wanted to use the resulting data from the MAB algorithm for estimating the causal price effect or the product effect on conversion? Here we have to be concerned about a selection bias. Now, this happens when the assignment mechanism of the next best action will depend on profile characteristics. So this will mean that the causal estimates are going to be biased and typically would be underestimated. What we can do is compute, if we have the ability to compute the inverse of the propensity score to select an action, we can use this to potentially eliminate the bias. Using the exponent 4 algorithm, the propensity score for taking the specific action for a given profile at every step are known, and we can store that information and use it to debias the resulting selection bias. I'm not going to go into details about the exponent 4 or how
the formula seems very simple, Reuven.
Yes, exactly. It has a lot of parameters, so I'm not going to go into the details, but I encourage and welcome all of you to contact Nimrod Maniv and Luba Orlovsky from the analytics team. They'll be happy to discuss this details with you, and potentially also all the other MAB algorithms. So typically when we obtain the correct effect, in addition to obtaining the correct effect of price or the product offering, we are also interested in estimating other effects. I think we mentioned the regulatory part. We have to be transparent about what's going on. So we need to also understand how other factors could potentially impact conversion, for example, like demographics. So on this slide, what we are seeing is a simulation of different methods to try and handle the bias, GLM, general linear model, a weighted GLM where we use the weights as the inverse of the propensity scores, and an inverse propensity score weighting, kind of a computation, but on top of that, we will need a separate model for estimating the other effects like demographics, and then we will combine them together. What we see that the figures in the table represents the selection bias reduction in percentages. So if we have the 100% is within the confidence interval, this means that the selection bias was fully handled, or we have a fully debiased kind of result. The GLM reduced the selection bias, but not completely. And in the case of in this example, the price increase reduction is relatively mild. What happens is that the GLM corrects for the bias in a partially, as it includes in the model some of the variables that affect the selection probability. When we look at the weighted GLM, this corrects the selection bias, but in this case, the correction is actually too big, resulting in a bias at the other direction. And when we look at the inverse propensity score, this actually provides unbiased estimator of the causal effect.
Interesting. Reuven, you have one more minute, so if you can conclude, that would be great.
I'm running. It's maybe we'll take away from the question. So I don't see the watch actually on my side. So it's important to know.
I gave you the 5 minutes of the question to continue.
I'm rushing. It's important to know that this is just simulation. We can get some different results. So what we did to check the effectiveness, we ran some sort of a simulation in order to see the effectiveness of this simulation, and we look at also impact on the reward, and we compared between the random and the MAB algorithm. Reward could represent a different KPI, profit volume, or customer satisfaction level, or risk level, or a combination of those. And we can also introduce some constraints through a penalty function. So what we see is that when we look at the results here, what we did a simple price test. 3 groups, 60% are assigned to the control, no price change, and the rest, the other 40%, are split between the -5 and +5. The chart on the right shows a comparison between the MAB algorithms relative to the pure random test, and we can see that very quickly the MAB will provide an uplift relative to the random price test. But more importantly, the chart on the right shows a comparison with the base strategy of no changes. So what we can see that after 10,000 observations, the MAB algorithm is performing in a similar manner to the standard strategy, which means that the result, we are getting random data and it comes with no cost. So in conclusion, what we saw that the MAB can take advantage of continuous learning and the exploitation trade-off to improve the KPI. If we use the exponential 4 algorithm and we apply the right debiasing adjustment, like the inverse of the propensity score, this will result in unbiased causal estimate. And the fact that we can get randomized data without any cost is very powerful, allows us to leverage it in multiple ways to estimate the conversion models, and then based on that, set up optimal strategies, let's say for product personalization or for pricing. I will say that, of course, there are situations where people are using the MAB algorithms for both to learn and to make decisions. This, when we have very dynamic markets or where we have a short-term campaigns, where we don't really have time for this full cycle of randomization modeling and decision cycle. So thank you again for joining me today. Please feel free to reach out to me or anyone at Ernix, and please join me tomorrow actually for the AI and ethics sessions that I'm going to moderate. And back to you, Professor Amiram.
Thank you, Reuven, and much appreciated. It's fascinating. Some of my work was about causal inferences, and indeed does natural experiments, and I'm fascinated by this method. It's actually pretty cool. So while we're waiting on Ami to go up, so we don't really have time for questions, but I'll introduce Ami in the meantime. So Ami Tavori is, Reuven, can you stop sharing, please?
Yes, absolutely.
Thank you.